Imagine a future where your meals are filled with plant-based meat alternatives and your car runs on an electric battery, all while you believe you're making choices to save the planet. It's a vision that's been sold to us as the ultimate green utopia. But what if the truth is far more complicated? Both fake meat and electric vehicles, often promoted as the heroes of climate change, carry hidden environmental and ethical costs. Beneath their eco-friendly image lies a story of unintended consequences that might make you question whether these solutions are as green as they seem. Let's take a closer look at the untold environmental costs behind these so-called sustainable products. Plant-based meat has surged in popularity, marketed as the ethical alternative to traditional animal agriculture. From burgers to sausages, it promises the taste and texture of real meat with a fraction of the environmental impact. But here's where the illusion begins to crack. The production of fake meat relies heavily on monocropping, an agricultural method where a single crop, like soy or peas, is grown over vast expanses of land year after year. While efficient, this approach depletes soil health, strips away nutrients, and creates a dependency on chemical fertilizers. The result? Barren landscapes that require even more chemicals to sustain future crops. Monocropping also leads to a significant loss of biodiversity, turning once vibrant ecosystems into sterile fields where only one crop is allowed to thrive. This loss affects everything from pollinators like bees to wildlife that depend on diverse habitats. Beyond farming, fake meat requires enormous amounts of water and pesticides. Growing soy or peas at industrial scales often consumes as much, if not more, water than traditional livestock farming. Pesticide runoff from these fields contaminates local water sources, harming aquatic life and polluting ecosystems.
Once harvested, these crops are subjected to heavy industrial processing to create the finished product.
The plant-based patties you see on store shelves are packed with additives, artificial flavorings, and stabilizers to mimic the taste and texture of real meat. The energy-intensive nature of this process generates significant carbon emissions, diminishing the environmental benefits of choosing fake meat.
What began as a seemingly sustainable choice often ends up being far less green than advertised.
Electric vehicles, on the other hand, are hailed as the future of sustainable transportation, with promises of zero emissions and a cleaner planet. While EVs do eliminate tailpipe emissions, the environmental cost of producing their batteries paints a different picture. Lithium-ion batteries, the backbone of EV technology, require raw materials like lithium, cobalt, and nickel, which are extracted through destructive mining practices. Lithium, often dubbed white gold, is mined in salt flats, primarily in Chile and Argentina. The extraction process depletes local water sources, drying up fragile ecosystems and threatening the livelihoods of surrounding communities. Cobalt mining, largely concentrated in the Democratic Republic of Congo, brings another layer of complexity. Beyond environmental degradation, cobalt mining has been linked to child labor and unsafe working conditions, creating an ethical dilemma that contrasts sharply with the clean image of EVs.
Producing EV batteries is also incredibly energy-intensive.
The mining, refining, and assembly of materials generate substantial carbon emissions. Studies suggest that the production of a single EV battery can result in as much CO2 as driving a gasoline-powered car for several years. Additionally, the global supply chain for these materials adds to the carbon footprint. Lithium mined in South America might be refined in China, shipped to Europe for assembly, and then distributed worldwide. Each step in this chain consumes fossil fuels, further eroding the environmental benefits of EVs. The challenges don't stop once an EV hits the road. Battery disposal poses a growing environmental threat. Recycling lithium-ion batteries is complex, costly, and not yet widespread. Without proper recycling infrastructure, many used batteries end up in landfills, where they can leach toxic chemicals into soil and water. Even when recycling is possible, the process requires energy and doesn't fully recover all materials, perpetuating the need for more mining. As the demand for EVs rises, so does the potential for massive amounts of battery waste, creating a new environmental hazard. One key issue that ties fake meat and electric vehicles together is their reliance on global supply chains. Ingredients for plant-based products and raw materials for EV batteries are often sourced from different parts of the world, refined elsewhere, and assembled into final products in yet another location. This dependence on long-distance transportation adds significant emissions to the life cycle of these goods. Shipping soy from North America to Europe for processing, or transporting lithium from South America to Asia, consumes vast amounts of fossil fuels. These supply chains are also vulnerable to disruptions from trade disputes, natural disasters, or pandemics, making them far less sustainable than they appear. The marketing behind fake meat and EVs often emphasizes their green credentials, But the reality is more nuanced. Greenwashing, the practice of portraying products as environmentally friendly without addressing their hidden costs, is rampant. Consumers are told that eating a plant-based burger or driving an electric car is a simple way to fight climate change. However, they're rarely informed about the soil degradation caused by monocropping, the water pollution from pesticides, or the environmental and ethical consequences of battery production. By oversimplifying these solutions, we risk creating a false sense of progress while ignoring deeper systemic issues. So what are the real solutions? When it comes to food production, regenerative farming offers a promising alternative. This approach prioritizes soil health, biodiversity, and carbon sequestration by mimicking natural ecosystems. By rotating crops, using cover plants, and integrating livestock, regenerative farming can restore soil health and reduce the need for chemical inputs. Supporting local, sustainable farms not only benefits the environment, but also provides consumers with healthier, more natural food options. For electric vehicles, improving battery technology and recycling infrastructure is crucial. Research into solid-state batteries, which require fewer raw materials and have longer lifespans, could revolutionize the industry. At the same time, investing in efficient recycling systems would help recover valuable materials from used batteries, reducing the need for mining. Localizing supply chains for both food and energy solutions could further lower emissions, making these systems more resilient and environmentally friendly. Ultimately, the promise of fake meat and electric vehicles as green solutions is more complex than their marketing suggests. From destructive agricultural practices to energy-intensive battery production, these products come with hidden costs that cannot be ignored. Real sustainability requires moving beyond superficial solutions and addressing the root causes of environmental degradation. By investing in regenerative agriculture, better battery technologies, and local supply chains, we can create a future that balances innovation with environmental stewardship. It's time to rethink the way we approach green solutions and focus on strategies that truly benefit the planet at every stage.